So today we will be talking about the Doppler effect. Now there are two areas where the Doppler effect can be applied to. One is sound and the other is light. In this example, we're going to show you a red object. In this case, we'll just say it's going to be an ambulance because an ambulance is an object that produces sound. So we're going to say that this ambulance creates a circular wavefront around it. And we're going to say that it also moves towards the right. So as it creates a circular wave, it'll move towards the right side of that wave. And so when it creates a new wave, basically that wave will be closer together on the right side and farther apart on the left side. Now note that the velocity is the same for every direction it goes, it's just that the object is moving closer to the right, so it's more crammed together, producing a higher frequency in sound.
For the Doppler effect, as the speed of the object increases, the waves are forced together or compressed because they cannot get out of the way of each other. Eventually, they merge together into a single shock wave, which travels at the speed of sound, which is also known as the critical speed Mach 1.
For a sonic boom, this becomes pretty interesting, as when an object moves towards the earlier wave that's created, you can see that the newer wave actually surpasses the older wave. That's because the object is traveling at or above the speed of sound, otherwise known as Mach 1. Start. Now, the Doppler effect doesn't only apply to sound, like I said earlier, because it also applies to light. This example isn't all that accurate, as Gina is not traveling at the speed of light. However, you can see that as Gina moves towards your point of view, she looks kind of blue, and when she moves away from your perspective, she looks red. This is because as she moves towards you, the light in front of her is squished, which means that she is on the blue end of the visible light spectrum. As she moves away from you, the light behind her is stretched, meaning that she is in the red area of the visible light spectrum. In summary, the Doppler effect is a very important concept in physics, as it's led us to perform implausible tasks, such as breaking the sound barrier. However, although we understand just about everything there is to the Doppler effect, there are still more things that we want to accomplish, such as traveling near the speed of light.